Hello everyone, today we are going to another topic, that is degree of freedom. Okay, so now degree of freedom. Here you can see three axes, that is x-axis, y-axis and z-axis. Okay, so an object in space has 3 degrees of freedom. Okay, so here you can see these 3 axes, that is the x-axis, y-axis and z-axis. Translatory motion along x, y and z-axis, that is 3 degrees of freedom, and rotary motion along x, y and z-axis, that is 3 degrees of freedom. So total we are having 6 degrees of freedom. Okay, the rigid body has 6 degrees of freedom in space, but due to formation of linkage, 1 or more degree of freedom is lost due to the presence of constraint on the body. The total number of constraints cannot be 0, as the body has to be fixed at some place to make the linkage possible. Thus the degree of freedom is given by degree of freedom is equal to 6 minus number of restraints. Okay, so here you can see the figure of that is one rigid, that is no motion, number B is prismatic, C revolute, D parallel cylinders, E cylindrical, F is spherical, G is planar, H slider, cylindrical slider, point slider, spherical slider and crossed cylinders. Okay, so here you can see in the bracket there it is written there degrees of freedom. Okay, so as you can see, prismatic 1 degree of freedom, revolute 1, parallel cylinder 2. Okay, so moving on to the next slide. Here in the table you can see, referring to the figure, that rigid there is 0 translatory motion and 0 rotary motion, so degree of freedom here will be 0. So total restraints will be 6. Okay, because it consists of 6 degrees of freedom in total. Okay, so next, prismatic, here 2 translatory, 2 rotary, so degree of freedom is 1 and restraint is 5. Similarly, revolute 3 2 1 5, parallel 2 2 2 4, cylindrical 2 2 2 4, spherical 3 0 3 3, planar 1 2 3 3, edge slider 1 1 4 2, cylindrical slider 1 1 4 2, point slider 1 0 5 1, spherical slider 1 0 5 1 and cross cylinder 1 0 5 and 1. Okay, so here is the explanation how the degree of freedom has occurred. Okay, so for figure A, that is the rigid figure, so the degree of freedom there was 0. So why 0? As there is no motion, hence degree of freedom is 0 there. Okay, so for B, the degree of freedom is 1. So as movement is possible only in Z direction, so the degree of freedom is 1. Similarly, for all the figures mentioned in the previous slides, all the explanations for all the respective figures have been given here, along with the table that has been in the previous slide, against the rotary, how many rotary motions and how many translatory motions were there. Okay, so here is the explanation of each and every figure present in the slide. Okay, next we move on to kinematic chain. So kinematic chain is an assembly of links which are interconnected through joints or pairs, in which the relative motions between the links is possible and the motion of each link relative to the other is definite. Okay, so here is the kinematic chain. Okay, this is the non-kinematic chain and this is the redundant chain. Okay, next, what is non-kinematic chain? So in case the motion of a link results in the indefinite motions of other links, it is a non-kinematic chain. Okay, the reason for this indefinite motion lies in the fact that if we give motion to any of the link in the chain, then the other links can take indefinite position. Okay, so next, number C is the redundant chain. So there is no motion possible in the redundant chain. It can be observed from the figure that this chain is locked due to its geometry. Okay, so next, degree of freedom in a mechanism. So degree of freedom of a mechanism in space can be explained as follows. Let n is equal to total number of links in a mechanism, f is equal to degrees of freedom, j1 is equal to number of pairs having 1 degree of freedom, j2 is equal to number of pairs having 2 degree of freedom, and so on. So when one of the links is fixed in a mechanism, if we fix one of the link in a mechanism, then the number of movable links are capital N minus 1, and the degrees of freedom of capital N minus 1 movable links is equal to 6 into capital N minus 1. Okay, because each movable link has 6 degrees of freedom, each pair having 1 degree of freedom imposes 5 restraints on the mechanism, reducing its degrees of freedom by 5j1. This is because of the fact that the restraint on any of the link is common to the mechanism as well. Other pairs having 2, 3, 4 and 5 degrees of freedom reduce the degree of freedom of the mechanism by putting constraints on the mechanism as well. So the degree of freedom can be given by f is equal to capital 6 into capital N minus 1 minus 5j1 minus 4j2 minus 3j3 minus 2j4 and minus 1j5. Okay, next, most of the mechanisms we generally study are two-dimensional in nature, such as slide the crank mechanism, in which translatory motion is possible along two axes, that is one restraint, and rotary motion about only one axis, that is two restraints. Okay, thus there are 3 general restraints in a two-dimensional mechanism. Okay, clear? Okay, therefore for plane mechanism, the following relation can be used for degrees of freedom, that is f is equal to 3 into capital N minus 1 minus 2 in j1 minus 1 j2. Okay, so let us consider one example here. Find the degree of freedom of the mechanism given below. Okay, so here you can see the figure of a mechanism. So here link 1 is the ground, link 2 is here link 1, both the links are ground. So here this is link 2, this is link 3, and this is link 4. Okay, and link 4 and 5, here it is double join. Okay, so double join is present between link 4 and link 5. Next is the link 6, this one, and this is link 7, and here this slider, okay, having reciprocating motion, is link 8. Okay, so next, here is the solution. Okay, so in total in the figure we have seen that there are number of links is equal to 8. So number of pairs having 1 degree of freedom is equal to 10 by counting. Okay, so how to calculate pairs? Now let's see how to calculate the pairs. So pair 1, link 1 ground and link 2 constitute a single turning pair. Okay, so pair 2, link 2 and link 3 constitute a single turning pair. Pair 3 is link 3 and link 5 constitute a single turning pair. Pair 4, link 4 and link 5 constitute a single turning pair. Pair 5, link 5 and link 6 constitute a single turning pair. Pair 6, link 6 and ground, that is link 1, constitute a turning pair. Pair 7, link 5 and link 7 constitute a turning pair. Pair 8, link 7 and link 8 constitute a turning pair. Pair 9, link 8 and ground link 1 constitute a sliding pair. And pair 10, that is link 4 and ground, that is link 1, constitute a turning pair. Okay, as all the pair calculated have 1 degree of freedom, so there is only one term j1 is used as it denotes the pair having single degree of freedom. So j1 is equal to 10 as all pairs have 1 degree of freedom. So capital F is equal to 3 into capital N minus 1 minus 2 into j1 minus 1 into j2. So if we put the values of capital N, J, so degree of freedom will come up as 3 into 8 minus 1 minus 2 into 10 is equal to 1. Okay, so the degree of freedom is 1 for this mechanism. Clear? So with this I would like to conclude this lecture. Thank you everyone.